Let's see another linked list problem from the LeetCode. It's removing the nth node from the end of the list. So there is a list here, and the n value is provided 2. That means from the end we need to remove this 4. So somehow, if you can remove this from here, and then if we link this 3 to 5, the goal will be achieved. We can do this easily. We can reverse this, and then once we have reversed, we know the n is equal to 2. We can remove that item easily, and then again we can reverse the second time. Then we can get this original the list here, but for that we need this in a 2 pass. But if you see here something like there is a constraints here, the number of the nodes here, like follow up, could you do this in a 1 pass? So we have to learn how to do in a 1 pass. So for this we need to use the slow and the fast pointer, but we need to figure out how to use the slow and fast pointer. So one thing we need to take care here, like if the n is 2, then we have to always maintain the distance between slow and fast pointer with 1. So that's we need to consider. If n is equal to 2, then n minus 1, that's 2 minus 1, that's the distance we need. So in order to achieve this, first what we do, we'll check that n is equal to 2, and we'll put the fast and the slow pointer here, and then we run a loop for n times, and then we move the fast pointer. So n is 2, so our fast pointer will be here at 3. This one time I'll move, and second time I'll move the fast pointer, so fast pointer will be here, and the slow pointer is here, and the distance between the slow and the fast pointer is 1. So we have to maintain this distance, and we have to keep traversing, and the time comes when the slow pointer comes to 3, and then we cannot move further. And then once the slow pointer comes here, then we can easily connect this to the 5 here, and we can achieve the this solution. So let's see again, dry run this in the case of n2. So the slow pointer and fast pointer is here, and then we move the fast pointer by 2 because n is 2, so fast pointer will be here, and then again we'll move the slow and the fast by 1. So slow come here, fast comes here, slow comes here, fast comes here, and then fast will not move again, and the slow pointer is here. So it's easy. Then from there, now we can connect to the next. So that's the technique we are going to use here. One of the the corner cases, like let's say you want to remove 5th item. Let's dry run for the 4, and then we'll again check for the 5th. That is the corner case. So let's say I want to delete 4th item, 1 2 3 4. 1 2 3 4, this 4th item I want to delete. So in this case again, first we need to move our fast pointer by 4. So the slow pointer and fast pointer will be here in the beginning, and then the n will be 4. Then we'll move by 4. So 1 2 3 4. So fast pointer will be here, and the slow pointer is here. The fast pointer we cannot move further, and then we know we want to delete this thing. Then slow pointer is here, then from here to next we can connect this, and this will be deleted. Now let's observe for another corner case. Like let's say I want to delete the 5th one. So our slow pointer is here, and the fast pointer is here. And then how to figure out to delete this one, because slow pointer is here, fast pointer here, and then let's say the 5th item we want to delete, then we need to move the fast pointer to the 5 times, then 1 2 3 4, then next is null. So fast pointer is here, slow pointer is here. How to figure out because the usual rule is we're thinking of from the slow we'll go to the next and connect that, and then in that way this will be deleted. But the slow pointer is here itself, then we cannot do. So that corner case we need to figure out. So for that, what I'm thinking, I can also maintain the count. The count I can maintain, like let's say the beginning, our count is 1, and when the fast pointer move to this place, then counter will be also move. So 2, 3, 4, 5, the counter will be 5, and then I can check our slow pointer and the head is same, and this is also the length of this whole things, the fifth, because we know the length is 5 because I cannot move further. So length is 5. So if this is the length is same, then in that case I can move the head here. So that's the corner case I'm thinking in that way. Let's try this. Okay, so let's write the code. First of all, I will put the slow pointer at head and also fast pointer at head, and then there is an end. So for is equal to 0, I less than n, and I'm going to move the fast pointer. So in this way, like if you take this example, then n is 2, then we'll move the fast 1 and then 2 here. The fast pointer comes here and the slow pointer is here. Now we'll move the slow pointer by 1, fast pointer by 1. So we need another loop for that. So for fast not nil and fast next not nil. So this condition is same like all the fast and slow pointer related problem. You can see the previous videos. So this condition, we always put this condition, then fast not nil, next not nil, and then we'll move the slow pointer by 1, and then fast also 1. So so here we have to move again slow and fast by 1. So slow dot next, and then fast dot next. Okay, so in this way we know fast was here, so fast comes here, slow comes here, fast comes here, slow comes here, and then easily we can connect this to this one. So next, so let's add this condition. So if slow not equal to nil and slow dot next not equal to nil, then I connect slow dot next is equal to slow dot next to now slow dot next. So this next will point to next like this one. So slow next point, slow next. So 3 points to 5. So that's we did. Let's run this. We need to achieve this case also. So let's add for that, like let's say for now I will say the node count, and in the beginning I can say 1. The node count here is plus, and here also we need to put the node count plus, and I can check the condition if head is equal to slow. So somehow the head and the slow, if the slow didn't move and slow and head is same, and we want to remove this item, then head and slow, and then node count is equal to this n. So node count is also fifth and n is also fifth. That means we want to remove this one. So in this case we can just move this head to here, head to head next. So I can say head is equal to head dot next, and I can put this in a else condition. So else let's try to run and see any other corner cases missing. Let's return this head from here because this needs to be returned. So return head. in case of 1, n is equal to 1, and we want to delete this item. So n1, and then let's try run this. The node count will be 1, and then we want to delete the first item itself. So our slow pointer and the fast pointer will be at the same place. Slow and the fast, that is for the case of the 1. Then and come to this place, I less than n, then I 0, and the n is 1, then again it will move by 1. So maybe let's handle this scenario separately, and we'll check, come back again. So I can say if there's only one node here, so I can say if head dot next is equal to nil, that means there is only one item. So that is a scenario for 1, and then we can also check if count is equal to 1, then output 1, expected return nil. Okay, let's try to run this again. Not a count, it's a n. Let's submit this and try. Sometime submit will catch another research here. Yeah, so this time you have head is equal to 1 2 n2. So I think we need to handle this like one node and the two nodes situations here, and then other will be handled by our code. So let's handle that also. So if head next is equal to nil, head next. So if I say this is the head and the next equals to nil, that means there is a 2 items is equal to nil, and in that case I can check if n is equal to 1. If n is equal to 1, that means we want to remove this one, then just head next equal to nil and return head. Else there is one more condition, else n is equal to 2, then we just else if n is equal to 2, then n is equal to 2, then we need to remove the first item. So just move the head to head next. I think that's the corner case for the two nodes we handle separately, and I hope this condition will run for other. Let's run this. Run is good. I think we need to submit. Okay, so I think this is good. It's a pointer issue somewhere, so it's a line 31. Yes. So this thing is good, I less than n, but we need to also check and fast not equal to nil and fast next not equal to nil. Let's run this time. less than n. Oh, this should be within. I less than n and fast not equal to nil, and fast next not equal to nil. So and is good. Let's observe this scenario. 1 2 3 and n is 3, so this should be handled here. Oh, node count, that's the problem. Node count is equal to n. I was supposed to give this thing. Okay, it's accepted. Let me, I think we do not need to handle the ones in a 1 or 2 because that was the wrong parameter we had to give. So let me remove one by one this condition and check whether it can accept or not. It's good. Let's remove this too. Okay, yeah, good. So yeah, so I think we are good. I think this can be handled with this conditions, so we need to use these conditions also, and that was the mistake here. So yeah, so it's good. So we put the slow pointer, fast pointer here, and then we are moving the fast pointer to the next item, but we need to also check when we move the fast pointer to next, then we need to check the fast pointer is nil or not. So we have to make sure it is not nil, and then only we can move the fast pointer, and the slow pointer will move by one, and then we can check this scenario, the node count 1 from the beginning, and else if, and the normal the pointing to the next node. So that's all for today. Thank you.